Hi, my name is Jeffrey Liu, and today I'll be explaining a problem from the competition F equals MA from the 2022 year from test number A, question number 22. So the problem goes like this. So we start off with a system. One is a block, and this block has a mass of 2m. And then this block is initially at rest on top of two identical wedges. Just think these two wedges are equal, and these two wedges both have a mass of m. And this whole system is on top of a frictionless floor. And the top angle of these two wedges are defined as theta. And we're asked to find that if this system is released, what would be the downward acceleration that the block will experience? And first thing to note is that it is definitely not just g, because obviously it's on top of the wedges, which will slow down its descent. So first, we can draw a free body diagram to model all the forces that are present. So starting with the block, the main force that is present is just Fg, the force of gravity, which in this case, well, we can just draw as Fg. And then we also have, since the block is on rest on top of these wedges and pushing down on them, due to Newton's third law, the wedges will push back on the block. So we can say that it has normal force N, and since these two things are identical, two wedges are identical, they both retard the block with equal force N. And on the wedges, due to Newton's third law again, it's pushing the block, when it's accelerating downwards, it pushes on the wedges, pushing them apart. So these wedges will experience acceleration outwards. And this is due to the equal force N that the block pushes down on the wedges. So in total, the wedges both have two equal and opposite forces on them, and the block is accelerating downwards. So now we can write our Newton's second law equations for both the y direction and the x direction. Because since the block only accelerates in the y direction, the wedges only accelerate in the x direction because of the floor. So net F in the y direction first equals, since only the block moves down, the mass that's moving down is 2m ay. And this equals, since gravity and these normal forces are acting in different directions, and we know it's accelerating downwards, we can write it as Fg, which is 2mg minus the 2n. And then using a bit of trigonometry, we can find that the component of n acting in the y direction will be n, what is this, sine theta. And then we do the same thing for the x direction, where we get n, using more trig, cosine theta equals max, because the only mass accelerating in the x direction is a mass of 1m from the wedge. Now we also, since we can't relate these two yet because there's too many unknowns, we can find another relationship. Since the block has to stay on the wedges for the majority, for the majority of the time accelerating downwards, we can find a relationship by looking at the plane, the reference frame of the wedge. When the wedge and the block are like this, we know that the wedge is accelerating this way at a force with the acceleration of a to the x, and the block accelerating down with the a to the y. We can note similar triangles and define that as theta. If the block is on top of the wedge, these two thetas have to be the same, because if they're not, then these triangles are not similar, and then something is off. That means the wedge has fallen away, which does not happen in this problem. So from this triangle, we find that tangent theta equals ax over ay. And this is especially important because now we can relate the accelerations in both these F-net equations. So coming with that, we get n cosine theta equals, what is it equal? Equals m ay tangent theta, right? And then we get n equals a sine theta over cosine squared theta. And this is after expanding tangent equals sine over cosine. Now that we have this and this system of equations, we can plug our value of n into here and then solve for ay. Now that we can get rid of n, and then we would only have one unknown variable. So plugging it in, we get 2mg minus 2. We get m-ay sine theta over cosine squared theta sine theta equals 2m-ay. And then we get 2mg minus 2 m-ay. That would be 1 plus tangent squared theta equals 2m-ay squared theta. Oh, that's an equal sign there. Yeah, equal sign. So then, since we know that 2mg equals 2m-ay 1 plus tangent squared theta, which we could find by bringing this 2m-ay sine squared theta over cosine squared theta to the other side and simplifying, we know that through Pythagorean identities, 1 plus tangent squared theta is equal to secant squared theta. So then we have the relationship that 2mg equals 2m-ay secant squared theta. So through equating our equation, we just get ay equals g over secant squared theta, which equals to g cosine squared theta. So that's our answer. Thank you.